So now, dear student, only few topics are left from the chapter number 4. One of them and most important in entire chapter, it's a most important topic whose name is projectile motion. So in this lecture we discussed everything about this projectile motion. First of all, definition. Actually, with the help of some examples, first of all I'll explain what is projectile motion. So first of all I'll give you a few examples of projectile motion. If you have something in your hand like stone or a ball, whatever, something is there in your hand, and if you throw that ball in upward direction, so it performs which type of motion? Look at that from the diagram. Suppose this is y axis and this is x axis. Okay, so this is xy plane. Now suppose you are standing here, and from this point, let's consider this is origin, and from this point one person throws something from the hand. So initially it goes upward, reach to the maximum height, and finally it has to be fall down on the surface of the earth because of gravity. And you throw the object at some angle with the horizontal direction. So if any object is thrown with some angle, so initially it goes upward, reach to the maximum height. After getting the maximum height, finally it has to be fall down due to gravity. Earth's gravitational acceleration, Earth's gravitational force finally attract the object towards the land. So finally it has to be fall down. So this type of motion is known as a projectile motion, and is very clear from the diagram that projectile motion is a two-dimensional motion, because during the motion object performs the motion in x direction also, and object performs the motion in y direction also. See, its x coordinate during the motion also change, and during the motion its y coordinate is also change. It means we can say that in projectile motion, particle or object performs x displacement as well as y displacement. It has velocity in x direction also, and particle has velocity in y direction also. So let's define the projectile motion. Acha, in the definition, for the more clarification, look at here. As I said in the previous theoretical points, okay, if object is thrown, suppose object reach here at this point. So we already studied in the previous topics, okay, at any point during the motion, at any point velocity is in the direction of tangent. So suppose object reach here, its velocity is in the direction of tangent, and this velocity has two components. This is the x component of velocity vx, and this is the y component of velocity vy. Suppose object reach here, its velocity is in the direction of tangent. Again, this velocity vector has two components, x component of velocity, y component of velocity. Okay, now suppose object reach at the maximum height. Here at maximum height, velocity is in the direction of tangent, and this velocity vector has only one component, that is vx. So remember, at maximum height, y component of velocity is 0. When it comes down here, suppose object reach here, its velocity is in the direction of tangent, and this velocity vector has again two components. This is x component of velocity, y component of velocity. When object reach here, its velocity is in the direction of tangent. This velocity vector has again two components, x component, y component. So what is the noticeable point from this diagram? You can see throughout the motion, in entire motion, look at that, x component of velocity remains in the same direction. It means during the projectile motion, horizontal velocity, we can say that remains constant, whereas vertical velocity, see, from the beginning to when the object reaches at maximum height, from here to here, See, vertical velocity, y component of velocity is in upward direction. At maximum height, y component of velocity is 0. And in a remaining half motion, y component of velocity is in downward direction. It means the noticeable point is carried out from this diagram. Always remember, during the projectile motion, horizontal velocities remains constant. We will prove in the mathematically we also prove this that during the projectile motion horizontal velocities remains constant, whereas vertical velocity is not constant, will be changed with the time. Okay. Moreover, finally, why object falls down? The reason is due to Earth's gravitational force, and we all know that gravitational acceleration is act on any object in downward direction, and value of gravitational acceleration we all know that 9.8 meter per second square on the surface of Earth. On the surface of Earth, this value is almost constant. So it means two physical quantities are constant in a projectile motion. If anyone asks you, okay, in projectile motion, which two physical quantities are constant? So remember the answer. Answer is, during the projectile motion, first one is horizontal velocity is constant, as well as acceleration is also constant. So it performs, projectile motion is the best example of motion in a two dimension with constant acceleration. So now let's write the definition of projectile motion. Projectile motion means if any object is thrown into Earth's gravitational field at some angle. If any object is thrown in the Earth's gravitational field at some angle, theta, at some angle, then it performs motion. Then it performs motion with constant horizontal velocity and constant acceleration. These two physical quantities are constant. It performs the motion with constant horizontal velocity and constant acceleration. So such a motion is called projectile motion, and that object which performs the projectile motion is known as a projectile only. Here I'll give you now few example of the projectile motion. Example number 1, I'll already mention that, throw the ball from your hand. Example number 2, if any football player kick the football, then motion of the football is a projectile motion. A bullet is fired from the gun. From the gun, a bullet is fired, so that bullet performs projectile motion. Imagine a water pipe. Imagine a water pipe. Water is flowing through the pipe, and if there is a somewhere in the pipe there is a small hole, so from this hole a stream of water comes out. A stream of water comes out from the pipe. That is also known as the projectile motion. So these are the few examples of projectile motion. So it's a basic introduction, basic information, understanding of projectile motion. Dear student, it's a big topic, most important. So many equations we are going to derive in this topic. So let's start this topic in a detailed way. Moreover, in this topic approximately 10 equations, more than 10 equations we are going to derive. Few of them are definitely present in our textbook, few of them is not available in the textbook, but entire topic we understand by considering the NEET or JEE examination also. So now let's move forward in the same topic, projectile motion, and let's start deriving few equations. So now, dear student, let's move forward in the very good topic, projectile motion. As I said, we derived so many equations in this topic, few of them out of textbook, few of them from the textbook. So after understanding the definition or a primary introduction for the projectile motion, look at this diagram. It's a diagram which represents the path. This is the path on which the object is performing projectile motion. And here it is also mentioned that object is thrown from here at an angle theta. Object is thrown at an angle theta. Let's consider this point from where the object is thrown. This point, let's consider it's an origin. So coordinate is 0, 0. Here initial coordinate x0, y0. That initial coordinate x0, y0 are 0, 0. Now object is thrown from here with initial velocity v0, where v0 is the initial velocity, and that initial velocity is in the direction of tangent. Now this initial velocity, we can think it's two component. This is the x component of initial velocity v0x, and this is the y component of initial velocity v0y. X component of initial velocity v0 cos theta, y component of initial velocity v0 sin theta. So here in this diagram, object is thrown from origin at an angle theta with initial velocity v0, where v0 has two component, initial velocity has two component, v0x and v0y. v0 cos theta and v0 sin theta. Okay. Now suppose after some time object reach here. Here its velocity is in the direction of tangent. Again this velocity vector has two component. This is the horizontal velocity, x component of velocity, vertical velocity, y component of velocity. Moreover, when object reach here, let's assume here the coordinate is xy. X coordinate is x, y coordinate is y. And we also know that during the projectile motion, acceleration is in the downward direction. Acceleration is in downward direction. And we know that if any vector is like that, then this vector has only one component. X component of acceleration is 0, whereas y component of acceleration is equals to g, because the object experiences gravitational acceleration. Minus g, why negative sign is there? So negative sign indicates that the gravitational acceleration is act in a downward direction. For the downward direction, I'll use the negative sign. So this is the diagram. Through this diagram, we are going to derive few equations. First of all, which equations we are going to derive? Number 1. See, it is very clear from this diagram that object performs during the projectile motion, object makes a displacement in x direction also, and it makes a displacement in y direction also. So let's first of all derive the equation of x displacement of projectile and y displacement of projectile. X displacement of projectile, and second equation we are going to derive y displacement of projectile. Then in this diagram is also clear, during the projectile motion particle has horizontal velocity also, vertical velocity also, because it performs 2D motion, two-dimensional motion. So next we derived equation number 3, we are going to derive now horizontal velocity, and fourth one we are going to derive vertical velocity. So first of all we derive this 4 equation. Remaining equation can be derived from this 4 equation. Okay. Now try to recall the previous topic. Our previous topic is equation of motion in a plane with constant acceleration. If you want to find the x displacement, final x coordinate minus initial x coordinate gives you x displacement. For example, initial x coordinate is this one. After some time when object reach here, its x coordinate is x. So final x coordinate minus initial x coordinate gives you x displacement. Similarly, final y coordinate minus initial y coordinate gives you y displacement. Now if you remember this equation of motion, v0 x t plus 1 half ax t square. Similarly here y displacement v0 y t plus 1 half ay t square. So we use this equation to find the x and y displacement. Okay. Now let's put the value from this diagram. X. Initial x coordinate is 0. Okay. v0x means x component of initial velocity. Look at here. X component of initial velocity v0 cos theta into t as it is plus 1 half. Achha, now in projectile motion, x component of acceleration is 0 into t square. So that term will be turns to 0. Final equation, x is equals to v0 cos theta into t. So this equation, through that we can find the x displacement. Let's call it equation number 1. Just observe this equation. v0 is the initial velocity, theta is the angle of projection, okay, at which angle you throw the object, and t is the time. If you have these three information, then from this three information we can find the x displacement. For example, I'll tell you one example. If MCQ is like that, okay, object is thrown at an angle 60 degree, object is thrown at an angle 60 degree with initial velocity 10 meter per second. So after 2 seconds, what will be its x displacement in x direction? It makes how much displacement after 2 seconds? So through that formula we can find the x displacement of the projectile. In the same way, now y displacement y minus y0 is the initial y coordinate is 0 minus, now this is y component of initial velocity, that is v0 sin theta, v0 sin theta into t as it is plus 1 half. Ay is the y component of acceleration, and y component of acceleration which is minus g and into t square. So finally it gives us y is equals to v0 sin theta t minus half gt square. This equation, through that we can find the y displacement of the projectile. Let's call it equation number 2. Again, if you have a three information, okay, object is thrown at what angle with what initial velocity and time duration is given to you, then you can find the y displacement of the projectile, and through this equation you can find the x displacement. These are the first two formula. Most important thing, as I said earlier, that in this topic we are going to derive 10 or more than 10 formulas. But my request to all of you, if you are unable to remember this formula, it means you are unable to solve any MCQ or any sums related to projectile motion. So it's my humble request to all of you, whatever the formulas that we derived in this entire topic, you should recall this all formula, you should remember all formula, otherwise you are unable to calculate any sum or any MCQs. So x displacement is v0 cos theta t, y displacement is v0 sin theta t minus half gt square. Now let's derive the formula of horizontal and vertical velocity. Okay, if you remember, in the previous topic we derived this equation of motion, v equals to v0 plus at, v equals to v0 plus at. Now if you want horizontal velocity, x component of velocity, so you have to put x component of initial velocity and x component of acceleration. Similarly, v is equals to v0 plus at. Now if you want vertical velocity, y component of velocity, then here you have to put y component of initial velocity and y component of acceleration. Let's put the value. Vx is equals to, now v0x, that is initial velocity x component, v0 cos theta, plus by during the projectile motion x component of acceleration is 0 into t, so that term turns to 0, vx equals to v0 cos theta. This is the equation number 3, gives us the horizontal velocity. We come again in this equation to conclude one thing, but before that Look at here, y component of velocity v0y, y component of initial velocity v0 sine theta minus y component of acceleration minus g into t. So this is the vertical velocity equation number 4. Now look at these two equations, horizontal velocity and vertical velocity. Just before some time in the introduction, when we understand the definition of projectile motion, so if you remember the definition, so in the definition I'll mention that during the projectile motion, horizontal velocity throughout the motion, horizontal velocity is constant, and it's proof also. Look at here, in the equation of horizontal velocity, look at that, there is a no time t is not present in this formula. Whereas in the equation of vertical velocity, look at here, time t is present. It means that if time is changed, for example, after 1 second object is here, after 2 second object is here, here, with the change in time, definitely vertical velocity will change with time, whereas horizontal velocity will not change with time, because there is a no time, term of time is not present. It means from this equation number 3 we can conclude that horizontal velocity does not depends on time. Horizontal velocity remains constant. So these are the 4 formulas. Now as I said that we are going to derive more than 10 formulas, but now remaining formulas we are going to derive using this 4 equation. So please keep this 4 equation first of all in your mind. I'll repeat this all 4 equation without observing towards the board. In the same way, in future, you should remember all the formulas without observing in the notebooks, in the textbook. First one, horizontal displacement, x displacement, that is v0 cos theta into t. Vertical displacement, y displacement is v0 sin theta t minus half gt square. Horizontal velocity v0 cos theta, and vertical velocity v0 sin theta minus gt. So remember these 4 formulas, and now next formulas we definitely get using these 4 equations. We use this 4 equation to derive the other formulas. So now after getting this 4 equation, x displacement v0 cos theta into t, y displacement v0 sin theta minus half gt square, horizontal velocity v0 cos theta, and vertical velocity of projectile v0 sin theta minus gt. These are the 4 formulas we derived. Now next, which formula we want to derive? So the first one is, we would like to know, dear student, time taken to reach at maximum height. Suppose if you throw the ball from your hand, how much time it will take to reach at maximum height? Suppose from the point of projection, it will take how much time to reach at maximum height? 10 seconds, 2 seconds. We can get the answer if we have some formulas. So let's find. And moreover, as I said earlier, that remaining all formulas we can derive using these 4 formulas. Okay, so which logic is involved? Look at here. This is the point of projection. Object is thrown from here, and we would like to know that it will take how much time to reach at maximum height. Remember, this is only the place at which y component of velocity is 0. During the projectile motion, at maximum height, velocity has only one component, x component. At maximum height, y component is 0. So suppose object will take time tm, time to reach at maximum height. T is equals to tm. Object reach here in this time. So here y component of velocity is 0. So let's select the equation number 4. In equation number 4, if I'll put time t is equals to tm, it means that object reach at maximum height. And object reach at maximum height, it means that over there y component of velocity is 0. So let's select the equation number 4. In equation 4, if we put t is equals to Tm, then Vy equals to 0. So let's select this equation, y component of velocity V0 sine theta minus gt. So in this equation I'll put time t equals to Tm, means object reach at maximum height, and object reach at maximum height, so that y component of velocity turns to 0. Now this negative term, take it on the left hand side, so Gtm is equals to V0 sine theta. So Tm is equals to V0 sine theta upon G. This G is shifted in the denominator. So look at this equation, is the equation number 5. Is the equation to find the time to reach at maximum height. Agar if you have only two information, कि object is thrown at what angle and with what velocity, then you can find that how much time it will take to reach at maximum height. Suppose MCQ comes in front of you, कि object is thrown at an angle 30 degree with velocity 10 meter per second. It will take how much time to reach at maximum height? So through that formula, by substituting this value, we can get the Tm. Value of G is familiar, 9.8 meter per second square, gravitational acceleration. So this is the formula through that we can get the time to reach at maximum height. Now next one is time to flight, TF. Achha, time to flight means total time from takeoff to take landing. Object, projectile, will take how much time to complete the motion. Object is thrown from here, it will take how much time to complete the motion, total time. Okay. One concept that I want to tell you, agar object will take 2 seconds to reach at maximum height, then it will take 4 seconds to complete the motion. Agar object will take 5 seconds to reach at maximum height, then it will take 10 seconds to complete the motion. Means that time to flight is double than Tm. Let's prove this, and also using out of this 4 equation, which equation we use to derive that equation. Okay, now look at here. Object is thrown from here and its motion is completed over here. Object is thrown at an angle theta. Achha, when object finally falls down on the earth, at this point its y displacement is 0, and suppose object take time t equals to tf to complete the motion, and when the particle complete the motion, its y displacement 0. So let's select this equation number 2. In this equation number 2, if I'll put t is equals to tf, it means that motion is complete. Motion is complete, it means that y displacement is 0. So let's select the equation number 2. In equation 2, if we put t is equals to tf, then y is equals to 0. Okay, so let's first of all write y displacement formula. Y is equals to V0 sine theta t minus half gt square. So in this equation I'll put t is equals to tf. T is equals to tf, it means that motion is completed. Motion is completed, it means that y displacement turns to 0. Again take this negative term on the left hand side, so 1/2 g tf square is equals to V0 sine theta tf. Okay, 1 tf cancel from both the side. This tf, okay, is equals to 2 will shifted on the right hand side in the multiplication of V0 sine theta, and this g will go in the denominator. So look at this equation, is the equation of time to flight. Let's call it number 6. And now look at this 2 equation. Only there is a 2 ahead in this formula. Look at the equation of time to reach at maximum height is V0 sine theta upon g, and total time to complete the motion 2V0 sine theta upon g. As I said that it will take double time. It means that from this 2 equation we can write that Tf is equals to 2 Tm. Tf is equals to 2 Tm. Time to flight, to complete the motion, is double than the time to reach at maximum height. Remember this. Now next formula, we would like to derive the formula of maximum height. So many times in a routine language we use this word कि भाई a ball is thrown, it goes how much far and how much high. So this is how much high. If object is thrown, it attains some maximum height. So how much the maximum height gained by the object? So it means that maximum height is nothing but the maximum y displacement. So let's derive the equation of, again use this equation. Look at here. Suppose object is thrown from here and this is the maximum height gained by the projectile. Maximum height means y displacement is equals to maximum h. And we know that object will take how much time to reach here? So t is equals to tm is the time to reach at maximum height. So again I'll use the second equation. See the logic behind the second equation. In the second equation, if I'll put t is equals to tm, t is equals to tm, it means that object reach at maximum height. And object reach at maximum height means that y displacement become maximum. So let's use the equation number 2. In equation 2, if we put t is equals to tm, then y displacement is maximum, become h. So again I'll write the equation of y displacement. Look at the y displacement is v0 sine theta t minus a half gt square. But in this equation I'll put t is equals to tm, t is equals to tm. So t is equals to tm means object reach here, and here it means its y displacement become maximum is equals to h. Now let's substitute the formula of tm. We have the formula of tm. So let's put this value in this equation. So h is equals to v0 sine theta as it is. Now tm means v0 sine theta upon g, value of tm v0 sine theta upon g, minus minus 1 half g. Acha tm square means v0 square sine square theta upon g square. So this value of tm we substitute in this formula. Now further simplification, h equals to v0 sine theta, again v0 sine theta means v0 square sine square theta upon g minus, acha here 1 g cancel with this denominator, this is 1 half and v0 square sine square theta upon g. It's simple, 1 minus 1 half. अगर आप 1 में से 1 हाफ सब्सट्रैक्ट करेंगे तो 1 हाफ फिर बचेगा. सिमिलरली v0 स्क्वायर साइन स्क्वायर थीटा अपॉन जी माइनस हाफ v0 स्क्वायर साइन स्क्वायर थीटा अपॉन जी. तो रिमेनिंग आंसर इज v0 स्क्वायर साइन स्क्वायर थीटा अपॉन 2g. So this is the formula number 7. Through that we can derive the maximum height. Agar only you have two things, कि object is thrown at what angle and object is thrown with what velocity, then you can find it will take how much time to reach at maximum height, what will be the total time to complete the motion, how much high it goes, maximum height. So everything is obtained. Now still we have 7 formulas. Still so many formulas are remaining to derive. Let's move forward in deriving the other formulas.